It does not, right? It does not alter the composition. Why? And shatters on the ground. What is that? Physical change, right? So this is a physical change, this is a chemical change. So that's going to be the answer. But let's look at the other ones. Lighting a piece of paper on fire and the paper burns up and leaves ashes. What is that? That's going to be a physical, nope, that's not a physical change. Nope. Burning. That's a key word. Yes, chemical change. Perfect. Baking a birthday cake for your mother. That's going to be a chemical change. Why is that a chemical change? Yeah, it changes the composition. Perfect. Because you cannot bring that cake back to its original form, right? You can't do that. Convert 254, 998 meters to kilometers. So you want to go from meters to kilometers. How many meters are in 1 kilometer? 1,000, right? So you're going to divide by 1,000 or multiply by 1,000? Divide by 1,000, all right? So what is the answer? The answer is none of the above. All right, because the answer should be 245.998 kilometers. All right? Make sense? Yep. All right, number 4. Glycerol is a syrupy liquid often used in cosmetics and soaps. A 3.25 liter sample of pure glycerol has a mass of 4.10 times 10 to the power 3 grams. What is the density of glycerol in grams over centimeters cubed? So you're looking for the density of glycerol in grams over centimeters cubed. You have what? You have the volume, right? And you have the mass, right? What is the formula of density? Yep, mass, yeah. Density equals mass over volume. Perfect. So we have the mass, it's right here. Volume is in liters, right? We want it in centimeters cubed, right? How do we go from 3.25 liters to centimeters cubed? I have a hint right here, right? So we can go from liters to centimeters cubed, right? So you have 3.25 liters times 1 liter, and then on top 1,000 centimeters cubed, and that gives you what? 3250 centimeters cubed, right? Does that make sense? And then you can plug this one over here, and then plug in this one right here, and then divide. So yeah, so what's the answer then, if you divide them? If you divide the mass by the volume. What do you guys get? To the left? All right. So the answer should be 1.26 grams over centimeters cubed. Make sense? Yeah. Huh? I have to convert to centimeters cubed because they want the answer in grams over centimeters cubed, right?
Did you say the answer was 12.6?
Yeah, 1.26.
Okay.
Yeah, yeah. So know how to fix it. Are you sure you can't see that? You can? A little bit? Okay. But I'll read it, okay? I'll read it. All right. Let's move on. All right, perfect. So it says, which answer includes all the following that are chemical changes and not physical changes? All right? So we're looking for the chemical changes, not physical. So freezing of water, what is that? Is that a physical change or chemical change? That's a physical change. Guys, can you keep it down, please? Thank you. Yep. Is that better? All right, perfect. Great. So one, freezing of water is a physical change, right? Because you're not changing the composition, you're just freezing the water, that's it. Now rusting of iron. Rusting, that's a key word, right? The iron is being oxidized, right? So is that, what's that gonna be? A chemical change, perfect. 3, dropping a piece of iron into hydrochloric acid, H2 is produced. So you're producing something, right? So is that gonna be a chemical change or physical change? Chemical change, because you're altering the composition, right? 4, burning a piece of wood. Remember, burning is what? Chemical change, right? And then emission of light by kerosene oil lamp. This is a tricky one because for oil lamps that have kerosene, what's happening is that kerosene is getting burned, right, to produce light. So this is going to be a chemical change too. So the answer is going to be E. Make sense? Any questions? So 6. Round 156.852 to 4 significant figures. So you start with this one right here, with the left number, and then you start counting. 1, 2, 3, 4, so it's 0.8, right? But you look at the number next to it, it's a 5, right? So this 5 is on this 8 to go up by 1. So it's 156.9. So it should be B, C. Simple. 7. Calculate the following to the correct number of significant figures. All right, so when you're multiplying and dividing, what is the rule for that? Yep, the fewest number of sig figs, right? So we're gonna use PEMDAS, right? Right, parentheses, exponent, multiplication, division, addition, subtraction, correct? So we're gonna start from the left and then we're gonna move to the right. So 27.5 times 1.82 is what? 1.82, that's going to give me 15.05, okay? 50.05. But this one has 3 significant figures, and this one also has 3 significant figures. So this one should have 3 significant figures too. So 1, 2, 3, right? So I'm just gonna underline the 0 because I don't want to round just yet, okay? I'm just underlining it so that I can keep track of how many significant figures this number has, okay? And then I'm gonna divide by 100.04. There you go. You're still dividing. Remember, this one has 3 significant figures, and this one has 1, 2, 3, 4, 5 significant figures, okay? So you're going to divide them, and you're going to get what number? What's the answer? Yep. Yep, it's A. Perfect. 7, 8. Any questions about that problem? All right. So calculate the following, number 8. Calculate the following to the correct number of significant figures. All right. So remember, PEMDAS again. So you start with the numbers in the parentheses first. So this one right here. So this is a multiplication, right? So we still need to find the one with the fewest number of significant figures. And which one is that? It's this one right here. This one has 6 sig figs, and this one 3, right? So our final answer should have only what? 3 sig figs. So we're gonna multiply them. So 2.38 times 24.6681, and I have that number. Remember, it has to be in 3 sig figs. It has to have 3 sig figs. So 1, 2, 3. All right? And then we're going to add 332.58. All right? What is the rule for addition and subtraction? You're going to look at the numbers, or the numbers after the decimal point to the right. Okay? So this one only has 1 sig fig after the decimal point, and this one has 2. So you gotta look for the one that has the fewest one, right? And that one is this one right here, right? Because it only has 1 after the decimal point. Okay? So you add them, and your final answer should only have 1 number after the decimal point. So 58.710078 plus 332.58. All right? So your final answer should be this. Right? But it has to be in 3, right? 3 sig fig. 1 sig fig after the decimal point. Because this one only has 1, and this one has 2. And for addition, again, we want only the one that has the fewest number of significant figures, which is this one right here. So the answer should be 391.3. Make sense? So the answer is A. Any questions so far? Yeah. Right, only for addition and subtraction, you look at the numbers after the decimal point to the right, okay? That's it. Questions? All right. Number 9, convert 154 centimeters to inches, okay? So we want to go from centimeters to inches, okay? So we're going to set it up, 154 centimeters times, we're going to use this unit conversion right here. We're going to put centimeters on the bottom because we want to cancel them out, right? So 2.54 centimeters, centimeters with centimeters, and we're going to put 1 inch on the top, right? And that gives us what? What is the answer? It's A, right? Should be 60.6 inches. All right? Any questions? Perfect. Yep. Like the unit conversion, like if that's going to be given to you? Probably, depending on your professor. Okay? So that. What do you mean if it's not safe? Oh, if you want the answer in the correct number of significant figures. Yeah, it has to specify, correct. So this is a unit conversion problem. This is not a sig fig problem. Okay. All right, number 10. So an acetaminophen suspension for infants contains 80 milligrams over 0.80 milliliters suspension. The recommended dose is 15 milligrams over kilogram body weight. How many milliliters of this suspension should be given to an infant weighing 14 pounds? Okay? Guys, can you close the door if you can, please? Thank you. Appreciate it. So, so what are we looking for? For volume, right? Milliliters, right? We're looking for this one right here. And we have 14 pounds. So first, I just want all the unit conversions. Let me write all the unit conversions. So we have 80 mg over 0.80 ml. That's the first unit conversion, okay? Then you move on to the next one. 15 milligrams over 1 kilogram, correct? That is the second unit conversion. And then you have 14 pounds. I'm going to use the word pounds because if I put lb, then it's going to look like 14, 16. So 14 pounds. And then you also have this hint, 1 kilogram over 2.205 pounds. So this right here, this unit conversion might be given to you depending on your professor, okay? Or else you just have to memorize it. So then you want to go from pounds, right? You want to go from pounds, 14 pounds, to ml, right? So you start with that, 14 pounds, all right? 14 pounds. Now, it's very simple. All you have to do is just look for the one that has pounds, this one right here. Okay, so 2.205 pounds, and then 1 kilogram, right? Pounds cancel out with pounds, correct? Now, look for the one that has kilograms, this one right here. Okay, so we're gonna bring this one down. Kilograms cancel out with kilograms, right? We don't want milligrams, we want ml, right? So we keep going. We're gonna flip this because we want milligrams on the bottom. So that way we can get rid of milligrams. And we're gonna bring this one on the top. Milligrams cancel out with milligrams and you're left with milliliters. All you have to do now is just multiply and divide, that's it. Then your answer should be what? It should be B, right? Questions? So now we're on chapter 2. All right, so the mass ratio of sodium to fluorine in sodium fluoride is 1.21 for every 2 to 1. A sample of sodium fluoride produced 28.8 grams of sodium upon decomposition. How much fluorine in grams was formed? Okay, so what law is this testing? Law of definite proportion or law of multiple proportion? Definite or multiple? 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 It's definite, right? So let me show you. Law of definite proportion, all right? What is that? It deals with the same compound, all right? Same compound. Okay? So a compound, so regardless of its origin, will always have the same mass ratio. All right? And what do I mean by that? Same mass ratio. So let's say you have H2O and 2H2O and 3H2O. They will all have the same mass ratio. They all of them are the same compounds, right? Same, H2O. But they will have the same mass ratio because for here, this one, you have hydrogen has a mass of what? 2, right? And oxygen has a mass of what? 16, right? So 16 to 2 is what? 8 to 1, right? Same thing, right?
Can you move it down, please? It's
Yeah.
going on.
Same thing for this one. 8 to 1, 8 to 1, right? It's going to be the same, okay? For the same compound, only for the same compound. What about law of multiple proportion? Let's do that one. Let me do it on the back. So law of multiple proportion, all right? All right, what is that? Law of multiple proportion. That's dealing with what? Two different compounds, perfect. Two different compounds, right? All right. And so, two different compounds with the same elements. Okay? And so the relationship BW is between the elements is a small whole number ratio. Okay? So let me give you an example. N2O or NO2. They are different compounds, but different compounds with the same elements, correct? Nitrogen and oxygen. Okay? And they're also going to give you numbers too. And then the numbers, once you put them in a fraction form, they has to give you a small whole number ratio for it to be consistent with this law. All right? Good. All right, so we're not done with that one. So it says the mass ratio of sodium to fluorine and sodium fluoride is 1.21 to 1. A sample of sodium fluoride produced 28.8 grams of sodium upon decomposition. How much fluorine in grams was formed? So we're looking for the mass of grams, the mass of fluorine, right? So we have this ratio right here. The ratio is what? 1.21 grams of sodium for every what? For every gram of fluorine, right? Mass ratio. This is the mass ratio right here. So what we're going to do is we have 28.8 grams of sodium, okay? But we want to find out the mass of fluorine. So we can use this ratio right here. We're going to put 1.21 grams of sodium on the bottom and then 1 grams of fluorine on the top, and that should give us the answer, right? What is the answer then? It's A, perfect. It is A. All right? All right, number 12. All right, it says, which statement are consistent with Dalton's atomic theory as it was originally stated? All right? So what is Dalton's atomic theory? I have it here. All right. All right, so Dalton's atomic theory, each element is composed of tiny indestructible particles called atoms. All atoms of a given element have the same mass. Atoms combine in simple whole number ratios to form compounds. Atoms of one element cannot change into atoms of another element. In a chemical reaction, atoms only change the way that they are bound together with other atoms. Okay. You guys need to know this right here. All right? All right. So we're looking for, we're going to start with the first one. Sulfur and oxygen atoms have the same mass. Is that consistent with Dalton's atomic theory or not? Yeah, you can, yeah. Is that consistent or not?
Yeah.
No. Sulfur and oxygen atoms have the same mass. Let me show you. Look at the periodic table. Do they have the same mass? No, they don't, right? So this is false. Okay? All cobalt atoms are identical. Is that true or false? That is true, right? Because all cobalt atoms are going to be the same. They're going to be the same, okay? And then potassium and chlorine atoms combine in a 1-to-1, so it's going to be true, 1-to-1 ratio to form potassium chloride. Is that true or false? True or false? Yeah. Wait, what was that? Isotopes? Well, this is not an isotope. This is an ionic compound, right? Potassium chloride, right? So you have potassium and you have chlorine. Number two? Cobalt atoms are identical. Yeah, they're just talking about neutral cobalt atoms. Yeah. Exactly, right. So KCl, is that the correct chemical formula? Right? Potassium has a charge of what? Plus, right? Chlorine, negative, right? So yes, 1-to-1 ratio. You guys see that? All right. Now lead atoms can be converted into gold. Is that true or false? That is false, right? You cannot go from one element to another element. You guys cannot do that. Okay, does that make sense? Right, because if you can do that, then let me know, because we can be rich together. Lead atoms can be converted to gold, so that is false. So then, what is the answer? 2 and 3, right? 2 and 3. Make sense? All right, 13. All right, so determine the number of protons and neutrons in the following isotope, okay? So the top number, this one right here, is what? What is that? That is going to be the mass number. The mass number. And the bottom one is what? The atomic number, right? So mass number equals what? Protons and neutrons, right? Whatever's in the nucleus. And then the atomic number is what? Equals what? Number of what? Protons, correct. It can also equal electrons only when it's a neutral compound, okay? If it's not a neutral compound, then it's going to have different number of electrons. So it says determine the number of protons and neutrons in the following isotopes. So protons is going to come from the atomic number. So you know it can only be A or C, right? A or C. What about neutrons? How do we get neutrons? Yep, perfect. We're going to subtract, right? 208 minus 82, and that's going to give us what? 126, right? A, right? Does that make sense? All right. 14. Determine the number of protons and electrons in the following ion. Okay, so Br negative, negative charge right there. So you know Br from the periodic table, Br has what? How many protons? Br is right here, right? 35, right? So it cannot be D. All right, so now we have a 33% chance of getting it correct. So next, negative. The negative charge tells you what? Do we add electrons or remove electrons? Add, sorry. Yeah, you're right, add. We're adding electrons, correct. We're adding electrons. So, and remember the atomic number equals protons, right? So we know we have, and for a neutral element of bromine, the number of protons is 35 and electrons is 35 as well, right? For bromine ion, for bromide, we just add an electron to this one, to this number, which is going to be 36. So the answer is A. Does that make sense? Because we're just adding one electron. And if it's positive, it's a positive charge, then we take away, okay? All right, any questions so far? All right, so 15. So which pair of elements do you expect to be most similar? Which one is that? C? You said C? Yep, it is C, correct. Let me show you why. Why is that? Huh? They're in the same row? Group, right? Group or family, right? Same thing. So Cl and F. So you look at your periodic table, Cl and F, they're in the same column, same group, same family, correct? So they have similar properties, okay? So if they're in the same group, they will have similar properties. So they're going to be very similar. So the answer is C. Perfect. All right. 16. An element has two naturally occurring isotopes. Isotope 1 has a mass of 120.9038 AMU and a relative abundance of 57.4%. And isotope 2 has a mass of 122.9042 AMU. Find the atomic mass of this element and identify it. All right. So let's first find the atomic mass of that element. All right. We don't know the element. So what formula are we going to use? We have to use a formula, right? So the formula is what? The formula is atomic mass of X of the element, in this case we don't know, equals the mass, AMU, of the first one, of the first isotope, and you multiply that by the relative abundance, Ra, relative abundance, of the first isotope, isotope 1. And then you add that to the AMU of isotope 2, and you multiply that by relative abundance of isotope 2. And if there was like a third one, then you do the same thing, and so on. So you keep going. So AMU, you're just gonna plug this number in over here, this right here. So it will be 120.9038. This is for the first isotope, times its relative abundance, okay? But we have to convert the percentage to what? Decimal, right? So we're just gonna move the decimal point to the left 2 times. So it's gonna be 0.574 plus AMU, right? Of the second isotope, which is given to you. How do we find relative abundance of the second isotope? Yeah, subtract it from 100. Yep. And that is what? So 100 minus 57.4, that should be 42.6. 42.6. Okay? And then all you have to do is just multiply and then add them. Does that make sense?
How'd you get the 42.6 again?
42.6, what I did was 100, because the relative abundance, they have to add up to 100%. Okay, so you have the relative abundance of the first one, which is 57.4%, and the other one must be what? 42.6%, right?
Would that be 0.426, like when you're multiplying?
Perfect, yeah. Good. Yeah. So 0.426, yeah. And then you multiply them and then you add them. Perfect. All right? And then that should be what? That should give you 121.8 AMU, right? Did you guys get that? And then we want to identify the element as well. How do we do that? All we have to do is just look at the periodic table, and we have to look for an element that has this mass, 121.8, which is what? This right here, right? What is SB? What is the name of that? Yep, antimony. Perfect. So it is B. All right. Let's move on. 17. Any questions so far? Nope. Okay. How many silver atoms are there in 3.78 grams of silver? Okay, so we're going from mass to atoms, right? Mass to atoms of silver, right? Right, mass to atoms. But to get to atoms, right? But to get to atoms, we have to go through which substance or unit? Moles, right? Perfect. So mass to moles to atoms. Make sense? So we have 3.78 grams of silver. We're going to multiply that by its molecular weight, which is right here. I wrote it. So it's 107.87 grams and 1 mole of Ag. So still silver. Okay? Now we have moles, right? But we want to convert moles to atoms. And to do that, we're going to use what? Avogadro's number, right? So 1 mole of Ag, silver, and then on the top, we're going to put Avogadro's number. Okay. Ag atoms. All right, and we can get rid of moles, and we're going to be left with atoms. And the answer is what? What is the answer? A, perfect, right? It is A. Make sense? Questions so far? All right. So 18. So calculate the mass in grams of the following sample: 1.1 times 10 to the 23rd gold, 23rd power gold atoms. So we want to go from what to what? We want to go from atoms to mass, right? So atoms to mass in grams, right? So we're going to do the same thing, but the other way around, okay? So 1.1 times 10 to the 23rd AU atoms, right? Times, we have to go through moles first, right? So we're going to use Avogadro's number again. So 6.022 times 10 to the 23rd atoms of AU. And then on the top, we're going to put a what? Moles, right? AU atoms. And to get to the mass, we have to use the gold's what? Molecular weight. Which is what? Yep, 196.97 grams. Right. And we're going to cancel out atoms with atoms. Atoms with atoms, and then moles with moles. And then we're going to be left with grams. This atom shouldn't be here, sorry. Yep. So it'll be atoms with atoms, moles with moles, and then you will get grams, which is the mass. Okay? And so the answer should be what? What is the answer? B, perfect. B. All right, so now chapter 3. Name the following ionic compound, CuNO2. Okay, so how do you name that? What is that? That's an ionic compound, right? Why is that an ionic compound? How do you know that's an ionic compound? I know it says it right there, but yeah, a metal plus a non-metal, right? In this case, what is this right here? NO2, what is that? That is nitrate or nitrite? Nitrite, right? So it's going to be, this is 2, CuNO2. So this is copper, This is nitrite, right? Because this is a what? A polyatomic ion, right? You guys have to know your polyatomic ions for the exam. Nitrite is this. Nitrate is NO3. Okay? And so, yeah. Any questions? Really quickly, I'm going to go over the rules for naming ionic compounds. What are the rules for an ionic compound? Yep. So the first rule, no prefixes, right? Ionic compounds do not have prefixes, right? What is next? You replace what? The suffix of the second element with "ide", IDE, okay? First element, the name of the first element stays the same, okay? But the second one changes, you just replace the suffix with, the last three letters with IDE. So bromine becomes bromine, for example. What else? What else is missing? Roman numerals, right? So if you have a transition metals, then you're going to put what? A Roman numeral. Yep, only for transition metals and also for PV, lead, right? Lead is not a transition metal, but you also have to use a Roman numeral for lead. And that equals what? Roman numeral. The Roman numeral gives you what? What does that tell you? The charge, perfect. The charge. Does that make sense? All right. All right. Number 20. So write a formula for the following molecular compound. Diphosphorus pentasulfide. Molecular compounds consist of what? Molecular compounds consist of what? Yep, nonmetal plus nonmetal, or what else? Metalloid plus nonmetal, right? If you have a metalloid and nonmetal, then you use the rules for naming molecular compounds. Okay? What are the rules? They have prefixes, right? But the first element does not have mono, right? Never for the first element. What about the second element? The second element has a prefix and a suffix, right? And the suffix is always going to be the same as ionic compounds, IDE. All right? Do molecular compounds have a Roman numeral? No, why? Right, because you only assign Roman numerals to metals, right? Transition metals. And molecular compounds do not have a metal, they have nonmetals, right? They have nonmetals and a metalloid, right? All right. So what's the answer then? Diphosphorus pentasulfide. What is that? D, right? Penta 5, right? Di 2. All right.
Number 19 represents you.
For which one? 19? 19 is A. No, sorry, it's B. It's copper 1 nitride, right? Copper 1 nitride. Yep. All right. 21. How many moles are in 25.5 grams of NO2? What is NO2? What is that? Nitrogen dioxide, right? Nitrogen dioxide, right? Do you see a charge right there? Okay. All right, so we want to go from grams, mass, to moles. Okay? So same thing. We're going to use the molecular weight of nitrogen dioxide. So 25.5 grams, right? NO2 times its molecular weight, which is 46.01 grams. NO2, 1 mole, NO2, right? And that gives me what? A, right? You should get 0.554 moles of nitrogen dioxide. Does that make sense? So if you're confused, the conceptual plan is this. If you want to go from grams to moles, you're going to use the molecular weight. If you want to go from moles to atoms, you're going to use Avogadro's number. Okay? If you want to go from atoms to moles, you're going to use Avogadro's number. If you want to go from moles to grams, you're going to use the molecular weight. Okay? And if you want to go from atoms to the mass, then you have to go to the moles. So that means you're going to use Avogadro's number and then the molecular weight. Make sense? All right, 22. Copper 2 fluoride contains 37.42 fluorine by mass. Calculate the mass of fluorine in grams, containing 55.5 grams of copper 2 fluoride. All right, so what formula are you going to use? There's a formula for this one. Does anyone know? All right, so it is the percent of X element, in this case is fluorine, right? The mass of the X element, fluorine, in that compound divided by the total mass of the compound, and you multiply that by 100%, right? Okay? So you have this percentage right here, so 37.42%, right, of fluorine, right? But to get rid of the 100%, you can divide both sides by 100, right? And this becomes what? 0.3742, right? Now we can get rid of the 100%. The mass of X, that's what we're looking for, right? Mass of X, of fluorine in this case. And we're going to divide that, so we can make that X, solve for X. And then on the bottom, we're going to put 55.5 grams of copper 2 fluoride. Okay? And so, what is the chemical formula of copper 2 fluoride? Does anyone know? Copper 2 fluoride. What is that? Copper 2 fluoride, right? It's going to be what? CuF2. You guys see that? CuF2. Okay, so we're just solving for X, and so the answer should be what? Should be A, right? Does that make sense?
You just multiply.
Exactly, I'm multiplying because I have to isolate X, right? Any questions so far? No? Perfect. Number 23. All right. So it says, calculate the empirical formula for the following compound. Okay? So every time you want to find the empirical formula, you're going to convert those numbers, the mass, to moles, right? You're going to go from mass to moles. Every time you see empirical formula, you want to calculate the empirical formula, you have to get it to moles first. Okay? So let's start with that. 1.651 grams Ag, right? Times the mass of Ag is 107.87 grams of Ag, 1 mole of Ag, right? And that's going to give us what? Moles of Ag, right? Which is what? 651 divided by 107.87, 0.01530546, right? And then you do the same thing with the other one. So you have 0.1224 grams of oxygen times its molecular weight, which is 16 grams, 1 mole of oxygen. Okay, so 0.1224 divided by 16. Wait. It's 0.00765. All right. So this is moles of Ag and moles of oxygen. Okay? So they become the subscripts. Okay? So let me do it over here. So you have Ag 0.01530546, and then, which is moles, okay? Or you can just write the number. And then oxygen 0.00765. And then to determine the subscripts, what you have to do is look for the one that is smaller. Which one is that? This one right here, right? So you divide both of them, both numbers, by 0.00765, 0.00765. And your answer should be what? What is your answer? B, right? Does that make sense? Any questions so far?
Wait,
Yeah.
So you divide them both by the smallest
Yep.
number of moles?
In this case, which one is the smaller number? This one right here, right?
Yeah.
So yeah, that's it.
So what did you do after that? After you divided it, how did you get the
Yep, that's gonna give me, for this one, you're gonna get 1, right? And then for this one, you're gonna get 2, right? That's the chemical formula, the empirical formula. Make sense? All right, perfect.
That was the thing where
All right. So 24. It says sulfuric acid is a component of acid rain formed when gaseous sulfur dioxide pollutant reacts with gaseous oxygen and liquid water to form aqueous sulfuric acid. What are the coefficients? And you have the chemical equation right here. This will not always be given to you. Your professor might just give you words, right? And you have to derive the equation. So make sure you know how to go from words to chemical formula, okay? So gaseous oxygen is going to be O2, okay? Liquid water, obviously H2O. Sulfuric acid, you have to go from naming to the chemical formula. And then sulfur dioxide is just SO2, okay? So then, on both sides, you have sulfur, you have oxygen, you have hydrogen, right? That's what you have on both sides. So let me draw a line in between. This is the left side, this is the right side, okay? Left and right side of the equation. Okay, so on the left side, you have how many sulfur atoms? You only have 1, right? Oxygen, you have 2, 4, 5, right? Hydrogen, you have only 2, right? All right, and then on the other side, you have only 1 sulfur, you have 4 oxygen atoms, and then you have 2 hydrogen atoms, right? So to balance the equation, what you have to do, you have to have the same on both sides, right? And so this one is the only one that is different, right? So what can we do? What coefficients can we put in here to balance the equation? What coefficients can we put?
Is this where you put in like 1/2? and
Exactly.
times it by 2?
You could use fractions too to make your life easier, right? So for oxygen, right, I want to bring this down to what? To 4, right? So to bring this down to 4, we can put a 1/2 over here, and now we have 4 oxygens on the left side and also on the right side. Does that make sense? Right? So this becomes 4, right? And now it's balanced. However, you can now leave the chemical equation with fractions. You have to what? Convert it to whole numbers. And to do that, you have to multiply everything by what? By 2, because I want to get rid of what? the fraction, right? I want to get rid of that, so I'm going to multiply everything by 2. If you multiply this by 2, you have to multiply everything by 2. Okay, so the answer is going to be 8. 2 times 1, 2 times 1/2, 2 times 1, and 2 times 1. Does that make sense? Questions? Okay. 25. Yeah, what's your question?
So when you multiply by 2, you only multiply the coefficients, right?
Yeah, the coefficients, right. 25. All right. Which of the following compounds is an inorganic compound? Okay, what is an inorganic compound? What is that? Okay. Inorganic compounds. Inorganic compounds are what? Molecular and ionic compounds. You guys are right, but let me just make it simple, right? And now organic compounds, what's that? They have a lot of carbon atoms. So a lot, okay? So if the compound has a lot of carbon atoms, then it will be an organic compound. So this is organic, this is organic, this is inorganic, this is inorganic. Because this is an ionic compound, this is also an ionic compound. So the answer is F. Yep, makes sense?
Could you say that one more time?
Yeah. Yeah, okay, so inorganic compounds are molecular and ionic compounds, okay? And organic compounds, they have a lot of carbon atoms, okay? And also hydrogen as well, and also other elements, but they mostly are in abundance of carbon atoms. They have a lot of carbon atoms, okay? Does that make sense?
Can organic compounds be ionic?
No, they cannot, yeah. So this one right here is an ionic compound, LiF, right? It consists of a metal and a non-metal, and then calcium carbonate consists of a metal and a polyatomic anion, right? So they are both ionic compounds.
Doesn't A still have carbon in it though?
Yeah, but it doesn't have a lot of carbon, right? And plus, it's technically an ionic compound because calcium is what? It's a metal, and CO3 is what? CO3 2 negative is what? Is a polyatomic anion. Perfect. Make sense? All right. Chapter 4. 26. All right. Limited reactant. So calculate the mass in grams of the product formed when 3.67 grams of magnesium completely reacts. Assume that oxygen is in excess. Okay, so we already know the oxygen is in excess, right? This is the excess reactant, right? So Mg must be what? The limiting reactant. Okay? We want to find the mass of the product. The product is this one right here, right? That's the product. So we can already eliminate B and D, right? So it can either be A or C. So to find the mass of the product, what are we going to do? How do we find the mass of the product when we have 3.67 grams of magnesium? How do I go from magnesium to magnesium oxide? Subtract? No, not subtract. That would be too easy, right? You got to use the molar ratio, right? So the molar ratio between them is what? 2 to 2 or 1 to 1, right? So 2 magnesium atom for every 2 magnesium oxide. Or it can also be, you can simplify it to 1 to 1. Same thing. And so it's what? Oh, right. Because, you're right. So you first have to convert it to moles. Why is that? Yes, I made a mistake. Why is that? Because the molar ratio is always in what? Yeah, molar ratio is always in moles. Moles over moles. So 3.67 grams of magnesium times what? It's molecular weight, right? Because we want to go from grams to moles first. So it's going to be 40.305 grams of magnesium, 1 mole of what? Oxygen of magnesium as well. And then we want to go from magnesium to magnesium oxide. We want to go from one element or one compound to another compound. So we want to go from one compound to another compound. We're always going to use what? The ratio, right, between them. So we're going to bring this one down over here to magnesium, 2 moles of magnesium for every 2 moles of magnesium oxide. So this cancels out with this one, and this cancels out with this one. And then we're left with moles of magnesium oxide, right? But we want the mass in grams, right? In grams. So we have to take another step. And what is that? What is the mass of magnesium oxide? Oh, wait. Sorry about that. Magnesium is 24, right? So this is 24, and this was the mass of magnesium oxide. So you have to put magnesium oxide on the bottom, and then grams of magnesium oxide on the top, which is 40.305.
Can you move it over, please?
Yep. I used the mass of magnesium oxide, but you had to use the mass of what? Just magnesium, right? To cancel out magnesium with magnesium, and then moles of magnesium with moles of magnesium, and then moles of magnesium oxide with moles of magnesium oxide to get grams of magnesium oxide. So yeah. All right. And so that should give you what? 8, right? 26A? Yep. Any questions about that? So remember, I went from grams to moles to back to grams, okay? So grams of magnesium to the moles of magnesium oxide, and then to the grams of magnesium oxide, because that's what we want. We want grams of magnesium oxide, okay? All right, 27. All right. So it says compute the theoretical yield of product in grams when the reaction mixture contains 2 grams of aluminum and 2 grams of chlorine. Okay? So how do we find the theoretical yield? Yeah. Yes, we have to find the limiting reactant. Perfect. And how do we do that? Do you know? Okay, so we want to go from the reactant to the product because we want to find the theoretical yield of the product, right? So we're going to go from Al to AlCO3 and then CO2 to AlCO3. Does that make sense? Yeah. What was that? All right, I'll zoom it in a little bit. Is that much better? I'll move it to the side, like that, a little bit. All right. Which one is the focus button? I don't know. So we want to go from Al to AlCO3 first. Let's do that. So we have 2 grams of Al, and we want to go to AlCO3. So we have to convert that to what first? To moles of Al, right? So grams of Al, right? It's right here, 27, right? And then on top, 1 moles of Al, right? My goal is to convert both of them to this compound right here. That's my goal, okay? So how do I go again from this compound or this element to that compound, AlCO3? The ratio, right? So it's going to be 2 to 2 or 1 to 1. All right. So what's the answer for that one? But we want it in grams, right? So we can continue if we want. But first, let's leave it in moles first. Let's leave it in moles, all right? So that way we can compare, okay? And that's what? What do we get? 2 divided by 27 times, okay, so it's just the same thing. 0.0740. All right, and that's moles of AlCO3. So I don't want to convert it to grams just yet because I want to compare both of them. Okay, and then, all right, and then I do the same thing with the other one. So 2 grams of CO2, right, times its molecular weight, which is 70.9 grams of CO2, and then 1 mole of CO2 times, the molar ratio is going to be different because now we have 3 to 2. So the molar ratio is 3 to 2. So 3 on the bottom, and then 2 on the top. And we get what? Is it this one? 0.01880583, right? Moles of AlCO3. So now all you have to do is just compare them. Which one is the smaller number? This one right here, right? So what are we going to do?
That's the limiting reactant.
That is the, no, this is not the limiting reactant. This is the limiting reactant, right?
Yeah.
And this is what? The theoretical yield, but in moles, right?
Mm-hmm.
So now we're going to go from moles to what? To grams, right? Mm-hmm. So this right here is the theoretical yield, and this right here is the limiting reactant. Does that make sense? All right. So now we're going to go from moles of AlCO3 to grams of CO3 because we want what? The theoretical yield product in grams. Does that make sense? So then we're just going to do 0.01880583 moles of AlCO3 times its molecular weight. We're going to put 1 mole on the bottom, and then on the top it's what? 133.35 grams of AlCO3. All right? And that should give us what? 27? What is that? We should get A, right? Make sense? Any questions? Huh? To the left? To the left? You said to move it to the left? To the right? Oh, you want to see this right here, right? Okay. All right. Any questions so far? Yeah. Yeah, you got to find the smaller one, right? The smaller one is going to give you what? The theoretical yield, right? And then the theoretical yield comes from what? The limiting reactant, right? Mm-hmm. Perfect. All right, 28. Any questions so far? Yeah. For the excess? Okay, let's do that. So if you want to find the excess, all right, first you find the theoretical yield, right? To find, why do you need the theoretical yield first? The theoretical yield gives you the limiting reactant, right? So now you know that this is what? This is the CO2 was the limiting reactant, right? And this is the excess reactant, right? So now, all you have to do is, you know, you want to find the excess, whatever is left, right? So So to do that, you have, you know that this is the limiting reactant, and this is the excess reactant. The excess reactant, we have 2 grams of, 2 grams of Al, right? So the excess, let me do it down here. So excess reactant is Al, right? And that is what? 2 grams Al, right? So to find the excess, all we have to do is convert the limiting reactant to the excess reactant, all right? And why do we want to do that? Go from the limiting reactant to the excess reactant. Do you know? Okay, because we want to know how much do we need of Al for the reaction to be complete, for the reaction to completely react, okay? To do that, we have to go from limiting reactant to the excess reactant, because the limiting reactant, we're going to use all of the amount of the limiting reactant, but we're not going to use everything of Al. We're going to use just a little bit of that, okay? So in this case, if you want to find the excess of what is left, you have to go from 3 CO2, right? 2 grams of CO2, right? I'm going to do it quickly. So you have 2 grams of CO2, and then you're going to use the grams, the mass of CO2, which is still 70.9, and then on the top is 1 mole of CO2. We want to go from CO2 to Al, okay? To do that, we're going to use the ratio, which is 3 to 2, right? 3 to 2, perfect. And then 2 moles of Al, right? And then we're going to go back to mass, to grams, which is 1 mole of Al equals 27 grams of Al. And then that should give you the mass of Al that you need. And then all you have to do is just subtract them, okay? Subtract whatever you get from here. So in this case, you're going to get what? You're going to get 2 times 2 times 27. So 108 divided by 70.9. 212.7. And that's going to give you 108 divided by 212.7. It's 0.50775, okay? So this is the grams of Al, right? So what you're going to do is you're going to do 2 grams of CO2, okay? Oh, no, sorry, Al, because Al is the excess reactant. So 2 grams of Al minus 0.50775 grams of Al, and that is your excess. Does that make sense? Okay. So 28. For 28, this is a dilution problem. So it says if 123 milliliters of a 1.1 molar glucose solution is diluted to 500 ml, what is the molarity of the diluted solution? What is the molarity of the diluted solution? How do we find that? What formula are we going to use? Huh? Yep, and 1v1 equals m2v2. So 1 is the initial, and then 2 is the final, okay? So what we're going to do is just plug in those numbers and solve for m2, the final molarity, right? Yep.
That's molarity equation.
Yeah, this is the dilution formula. Perfect. And we only use this formula when we only have one compound, okay? In this case, glucose, okay? If you have 2 compounds, 2 different compounds, then you cannot use this one right here. You're going to have to use a balanced chemical equation, okay? Because you're going to need the ratio, right? To go from one compound to the other compound, okay? So N1B1 equals M2B2. So you're going to plug them in, volume, molarity. The final volume is 500 ml, and then you solve for M2. You can leave it in ml as long as you stay consistent, okay? As long as you stay consistent, you're going to get the same answer, okay? So either convert both of them to liters or leave it in milliliters. Okay? Same thing. And what is the answer then? It's B, right? If you solve for M2. Make sense? All right. B1 is going to be, no, B1 is going to be this right here. And then M1 is going to be this one right here. And then V2 is this one right here. Yep. Does that make sense? Any questions? All right. So number 29. All right, let me read it. Complete and balance the chemical equation. If no reaction occurs, write no reaction. So how do we predict the products? Yep.
Is this where you go like K to S and Cl to Ca?
Right, K to S. You pair K with S and Ca with Cl. So you can think about that as outer and inner, okay? So you pair the outer elements with the inner elements, okay? So K with S and Ca with Cl. And that's because you want ionic compounds, right? You want a salt, right? You want salts. And so this is going to form what? So K with S is going to make what? What formula is that? Chemical formula. K has a charge of what? +1, and S 2 minus, right? So then the chemical formula is what? K2S, right? Perfect. And now you're gonna pair calcium with chlorine, right? Calcium has a charge of 2+, right? And then chlorine has a charge of what? Just negative, right? So then your answer is gonna be what? CaCl2, right? Does that make sense? But then we wanna make sure this is a precipitation reaction. Do you guys agree or not? Well, we have to check, right? Because the precipitation reaction involves what? What are you forming in a precipitation reaction? Yeah, a salt, right? So a soluble product and insoluble product. So if you do not have a soluble product and an insoluble product, then it's not a precipitation reaction, and so you will write no reaction, okay? And to do that, to determine whether it's soluble or insoluble, you're gonna look at the solubility table, which is this one right here, okay? So we know we have K2S, K right here. So any compound with potassium will be soluble, okay? So this is soluble right here, soluble, okay? Now CaCl2, you look for Cl, and the exceptions say when these ions pair with silver, mercury, or lead, the resulting compounds are insoluble. It's not paired with any of those, so it's gonna be soluble as well, right? They're both soluble, right? So then the answer is what? No reaction, right? Because you need a soluble product and an insoluble product, right? So the answer is E. Okay. So number 30. All right, so this is a titration problem. Okay. A 25 ml sample of an unknown HClO4 solution requires titration with 22.62 ml of 0.2 molar NaOH to reach the equivalence point. What is the concentration of the unknown HClO4 solution? First of all, how do you name HClO4? What's the name of that? Huh? No. No. HClO4. Without looking it up. Nope. Perchloric acid, right? Because this is saying oxyacid. You guys remember that? So perchloric acid. Okay? Because ClO4 minus, right, it's going to be perchlorate. And when you add the hydrogen, it's going to be perchloric acid. You just add the word acid. You drop the 8 and replace it with ic. Okay? All right, so let's solve this. So first, to approach this problem, what you have to do is you have to identify the unknown and the known. Which one is the unknown? The unknown is HClO4, right? So this is the unknown, okay? And NOH is what? The known, right? NOH and H, perfect. And then, so we don't have to worry. First, we have to balance the equation, okay? But it's already balanced, okay? But just make sure it's balanced. And so we don't have to worry about H2O and NaCl4. We don't have to worry about those compounds at all. So let's focus on those two. So we want to go from the known to the unknown. So from known to the unknown. We have 22.62 milliliters of NaOH and also 0.2 molars of NaOH, right? What do we need to do to go from the known to the unknown? So from one compound to another compound. The molar ratio, right? Always the molar ratio. So the ratio, right? All right? So to do that, the ratio is moles to moles, right? So we have to convert NaOH to moles first. And so we need what formula to get moles? Molarity equals what? Moles over liters, right? We have the molarity, right? We have the liters, right? We can convert this to liters, right? Which is going to be what? If you want to go from milliliters to liters, it's going to be what? 0.02262, right? We divide by 1,000, right? Because we're going from milliliters to liters, to big unit. So it's going to be in liters. So we're going to plug that in over here, and we're going to solve, and we're also going to plug in the molarity, and we're going to solve for moles. And that should give us what? So you have what is that? What is that, guys? You guys. All right. So it is 0.004524 moles of NaOH, right? We're still in that same compound, right? NaOH. Now we want to go from moles of NaOH to moles of perchloric acid, right? So all we have to do is use the mole to mole ratio. It's 1 to 1, right? So it's going to be the same number, right? So 0.004524 moles of HClO4, right? It's the same thing, right? Because it's 1 to 1. So now, what do we have to do? We want to find what? What are we looking for? The concentration, right? Concentration is the molarity, right? So we're looking for M. We have the moles, we have the liters, right? Liters of HClO4, which is right here, 25. We can convert milliliters to liters, right? Which is going to be 0.025 liters. And we're going to divide those two numbers, and we're going to get what? We should get B, right? Yep. So then we're going to use the same formula, So we're going to plug in this one over here, 0.00454 moles of HClO4 divided by 0.025 liters, right? And we should get this number right here. Make sense? All right, next question. Yep.
Why wouldn't you just use the M1 times V1?
Okay, remember, we're not going to use this one right here, right? Because this is only when you have the same compound. Here you have two different compounds. You have NaOH and HClO4. So when you have two different compounds, you cannot use this one right here. This is only when you have the same compound. In this case, we have glucose, and we end up with glucose. We're just adding water, right? So 30. All right, 31. Assign oxidation states to each atom in the following compound. All right, so Cr2O7 to negative. So how do we do that? Cr2O7 to negative. The charge tells you what? The charge equals the overall oxidation state, right? -2. So chromium is going to have an oxidation state of something as well as oxygen, and then when you add them up, it has to equal -2. So you have to follow the rules, okay? So the rules for assigning oxidation state. So which one comes first, chromium or oxygen? So let me just list out the rules, all right, for assigning oxidation states really quickly. All right. So 1, free element, right? Oxidation state equals 0, okay? 2, if you have an ion, oxidation state equals the charge. 3, neutral compound, overall oxidation state equals what? 0. Polyatomic ion, overall oxidation state equals what? The charge. Group 1 metals in the first column, have an oxidation state of what? +1, and then group 2, they have an oxidation state of +2. The 5th rule deals with nonmetals. So you can use whatever mnemonic you like, but I use FHO765, okay? I don't have words for those, but you can maybe come up with a mnemonic if you like. And so F is for fluorine, H is hydrogen, oxygen, O is oxygen, 7 is the 7th column, 6 is the 6th column, and 5 is the 5th column, all right? So fluorine has an oxidation, has a charge of what? -1, so that's the oxidation state. Hydrogen, +1, oxygen, -2, 7th column, -1, 6th column, -2, and then 5th column, -3, all right? So you have to know the rules, okay? All right? All right, 31. So which one comes first, based on the rules? Oxygen comes first, right? And oxygen has an oxidation state of what? -2, right? -2 times 7, because there are 7 oxygen atoms, gives you -14, right? Plus 2 times something gives you -2. You have to multiply the oxidation state of chromium by 2 because there are 2 chromium atoms, okay? So you have to solve for x. And what must x be so that it can equal -2? +6, right? So then the answer is what? C, right? Because remember, chromium has an oxidation state of +6. Oxygen has an oxidation state of -2, not -14, right? We got this because there are 7 oxygen atoms, okay? So it is C. All right? Any questions? All right, 32. So same thing, assigning oxidation states. O2 is what? It's a free element, right? So 0. H2O. We want the oxidation state of oxygen. So H2O. Which one comes first, hydrogen or oxygen? Remember, FHO765, right? So hydrogen. So hydrogen has an oxidation state of +1. Oxygen must have an oxidation state of -2. Because when you add them, +1 times 2 gives you +2, plus -2, or -2, gives you 0, right? It has to equal 0 because H2O is a neutral compound, remember? H2O is a neutral compound because you don't see a charge, right? H2O2, which one comes first? H or O? H, right? So +1, what must the oxidation state of oxygen be so that it can equal 0? -1, right? +1 times 2, -1 times 2, when you add them, it equals 0, right? It has to equal 0 because this is also a neutral compound, right? So the answer is A. All right, 33. 33. All right, so determine whether the reaction is a redox reaction. Identify the oxidizing agent and reducing agent. Yeah? Move it down. Okay. 33. So for 32 is A. Okay. Now I'm on 33. All right. So to determine the oxidizing agent and reducing agent, what do we have to do first? We have to what? Yep. Go back to which one? 32? All right. Yep. All right. Good? All right. 33. All right. So first, we're going to assign oxidation state to each element, okay? So HBr, let's start with that one. Which one comes first? Hydrogen or bromine? Hydrogen, right? Remember the rules, right? Bromine is in the 7th column, right? Hydrogen comes first, FHO 765. So plus 1, this must be minus 1 so that it can equal 0. Plus KOH. Which one comes first? Now, the one that comes first is potassium, right? Because it comes from the what? The 4th rule, right? So plus 1. Then which one comes next? Hydrogen, plus 1. Oxygen is minus 2. Add them together and you get 0. H2O. All right. Which one comes first? Hydrogen, all right, plus 1. And this must be minus 2. Plus KBr, right? Which one comes first? Potassium, plus 1. And this must be minus 1. Do you guys see that? Okay, so now to find the oxidizing agent, we have to find which one is being oxidized and which one is being reduced. We compare. Hydrogen, hydrogen stays the same. Bromine, bromine stays the same. Potassium, potassium stays the same. Oxygen stays the same. So what is this? No reaction, perfect. Because a redox reaction has what? An oxidation and a reduction, right? So no redox reaction. All right? Yeah.
So if it was like, what would a redox reaction be like exactly?
It will have an oxidation and reduction. So in oxidation, oxidizing state increases, right? Reduction, oxidation state decreases, okay? You first have to determine which one is being oxidized and which one is being reduced. And then after that, all you have to do is think opposite, all right? So if, let's say HBr is getting oxidized, then HBr is going to be the reducing agent, so just the opposite, okay? And so if KOH, let's say, was being reduced, then that will be the oxidizing agent, so just the opposite. So first determine which one is being reduced and which one is being oxidized. All right, chapter 6. All right, yep. Okay, so let me go back to that one. Are you talking about this one right here? Yep. So this, F is fluorine, H is hydrogen, O oxygen, 7th column, 6th column, and 5th column. Okay, make sense? Okay.
So why is it no reaction?
It's no reaction because you do not have an oxidation or a reduction, right?
Is it because they all come to 0? Or?
Yep, they're all the same thing. Any questions so far? All right. So 34 is just unit conversion. So like basically going back to chapter 1. So you have 534 kilowatts, and you want to go to kilojoules, right? So you're going to use the unit conversion. Again, this might be given to you or not. So 1 kilowatt equals 3.6 times 10 to the 6 joule, all right? But I don't want it in joule. I want it in kilojoules. So what I'm going to do is I'm going to use the conversion, the unit conversion between them, which is 1 kilojoule equals 1,000 joules, right? And then after you multiply and divide, you get what? 34 B, right? Make sense? All right, so 35. 35. Which statement is true of the internal energy of the system and its surroundings during an energy exchange with a negative delta E for the system? Okay, so delta E system equals negative. So what does that mean if the system is negative? It's losing energy, right? So if the system is losing energy, the surrounding must gain energy, the same amount of energy, right? According to the first law of thermodynamics, right? So the answer is D, right? The internal energy of the system decreases and the internal energy of the surroundings increase. All right. So 36. A system releases 622 kilojoules of heat. So that's Q, right? That's Q. Q is heat. And does 105 kilojoules of work. That's W, right? What is the sign of 622? Is it positive or negative? It's negative because it's releasing. The system is releasing, right? So it's negative. The system is doing work, so the system is working. It's doing work, so it's going to be negative 105, right? Make sense? And it's doing that on the surroundings. And then what is the change in internal energy of the system and surroundings? Well, the change in internal energy of the system is going to be what? You just add them, right? Because delta E equals Q plus W, okay? For the system. And that's going to give you what? Negative 727 kilojoules, right? So if the system loses that amount, the surrounding must gain the same amount. So it's A. Make sense? All right. Number 37. 37. So how much heat is required to warm 1.5 liters of water from 25 to 100 degrees Celsius? Okay, so you want to use what formula here? MCAT, right? So Q equals MCAT. All right. So you have the specific heat capacity, right? That's given to you of water. You have delta T, which is final minus initial, right? That's given to you. But you have 1.5 liters of water. You want grams of that. So you can use the density of water, right? So 1.5 liters times 1 liter equals 1,000 milliliters times what? The density, 1 ml on the bottom, 1 gram on the top, and that should give you what? The mass of water. So it should be 1500 grams. And so you plug that in over here, and then specific capacity of water is 4.18, and then delta T, change in temperature, is final, 100, minus 25 is 75, right? And so you just plug them in, you multiply, and you get what? What is the answer? The answer is A. Make sense?
Could you go over that one more time?
Okay, what part?
After you get the 1,500.
Okay, so this is the mass, right? So we're going to plug that in over here, right?
Oh, okay.
And then delta T is what? Final minus initial, right? 75, right? The final temperature is given, and the initial temperature is given as well.
Okay.
And then you get 75 degrees Celsius, you plug it in over here, and then specific heat capacity, C is the specific heat capacity, and that's given to you. Okay, so the specific heat capacity will be given to you. Yep. The answer is A. 37 is A. Yeah. For 36 is A. 36 is A. The answer is A, right. A for 36 and 37. Now 38. How much work in joules is required to expand the volume of a pump from 0 to 2.5 liters against an external pressure of 1.1 atm? All right, so you're going to use the formula. Work equals what? Negative P times delta T, right? Or delta B, sorry. Change in volume, right? So the change in volume is 2.5 minus 0, which is what? 2.5 liters. Liters, right? Times the the pressure, which is 1.1 atm, right? And the answer is going to be times -1, right? The answer is going to be what? 2.75, right? ATM times liters, right? But you cannot leave it in ATM times liters because work is always in joules. So you're going to use this right here. 1 liters times ATM equals 101.3 joules. And you multiply them, and you should get what? E, right? Does that make sense? All right, perfect. 39. Okay, so a chemical reaction that absorbs heat from the surrounding is said to be what? If it's absorbing heat, it's going to be endothermic, right? Exothermic releases heat, all right? And has a delta H at constant pressure. Delta H is going to be positive, okay? So endo gives you delta H equals positive, and then exo, delta H equals negative. Okay? Because exothermic reaction releases energy. All right? Perfect. 40. What was that? Oh, sorry. It's A. 39 is A. All right. 40. All right. So it's 40. A silver block initially at 58.5 degrees Celsius is submerged into 100 grams of water at 24.8 degrees Celsius in an insulated container. The final temperature of the mixture upon reaching thermal equilibrium is 26.2 degrees Celsius. When it says thermal equilibrium, that means that the final temperature for both substances is going to be what? 26.2 degrees Celsius. It's the same for the silver block and for the water. What is the mass of the silver block? We're looking for the mass of Ag. So we're going to use Q, this formula, QAg equals negative Q water. Because remember, this is positive because this is gaining energy and this one is losing energy. What? Right? One is positive and one is negative. So now we're going to expand both of them and use MCAT because Q equals MCAT. All right? This side is for silver and this side is for water. Okay? So we're just going to plug in numbers. So mass is what? The mass of the silver block is, we're looking for the mass of the silver block. This is our unknown. The specific heat capacity of silver is 0.235. Okay? So the specific capacity of silver is going to be given to you, so don't worry about that. Delta T is change in temperature, so it's going to be 26.2 minus 58.5, right? This is the final, this is the initial temperature of the silver block. So that is what? Negative 32.3 degrees Celsius, all right? All right, so the mass of water is 100 grams times C, which is the specific capacity of water, which is 4.18, times delta T. What is delta T? It's going to be final minus initial, so 26.2 minus 24.8 is going to give you 1.4. So then all you have to do is just multiply them and solve for this one right here. Got to solve for the mass of silver. Okay? Yep. So solve for the mass of silver. All right. So let me do that really quick. 0.235 times 32.3. I have 7.5905. It's going to be negative. And then 100 times 4.8 times 1.4 should give you negative 585.2, right? And then all you have to do is you divide both sides by 7.5 NO5, and you should get what? What is the answer? B, right? That's it. All right, so let's do the last one. The last one, 41. So this involves Hess's law, right? What's your question? This one? Okay. Do you have a question about that one? Okay. Let me do the last one, okay? Really quick. 41. So calculate delta H of the reaction, all right, for this reaction right here. So there are two important rules to find delta H. The first one is if you reverse the equation, okay, you're going to change the sign, okay? If you multiply the equation by a number, you multiply delta H by the same number, okay? So this right here is going to be our goal. We want to get this equation right here. And to do that, we're going to manipulate these equations right here to get to this one right here. So this is our goal. Let's call this the original equation, all right? So to do that, let's look at the first one. We have 1, 2, and 3. 3 equations, okay? So the first equation, we're going to compare the equation, the first equation, to the original one. So we have C5H12 on the left side. Here we have C5H12 on the right side. So we have to flip it, right? So let's flip that one. So we get 5CO2 plus 6H2O gives you C5H12 plus 8O2, right? And if you flip the equation, you're going to change the sign. So this is going to become positive, okay? Now the second equation, okay? You compare them. You compare the second equation to this one right here. And so you have carbon on the correct side, right? But you have 5 carbons here. You only have 1 carbon here. So what I'm going to do is I'm going to multiply the entire equation by 5. So you have 5C plus 5O2 gives you 5CO2, right? And so I'm going to multiply this by 5 too. But I'm not going to change the sign because I didn't reverse the equation. So now the last one, we compare this one to this one right here. All right? So we look, and we don't have oxygen, we don't have water, but we have H2, right? Here we have 6H2, here we have 2. So we have to multiply everything by 3, and we're going to multiply this by 3 as well. And so this is going to be 6H2 plus 3O2 gives you 6H2O, right? And it's also on the correct side, so we don't have to worry about that. So now we have to add them. And to add them, we have to see which ones are the same. So let's add the left side first. So first we can cancel out compounds, right? For example, we have 8 oxygens on the left side, right? 5 plus 3, right? And we have 8 oxygens on the other side, right? Because they're on opposite sides, they cancel out. Okay? And now, carbon dioxide. You have the same amount on both sides, right? And they're on opposite sides, so they cancel out, right? So then, what about water? Water cancels out too, right? So you're left with the original equation, 5C, 6H2 gives you C5H12. So it's correct. So what we have to do now is we have to multiply this by 5, this by 3. Then we change the sign here, and all we have to do is just add them. And after we add them, we get A. And that is it. All right? So thank you all for coming. Thank you so much.